Hello everyone and welcome to this special video because we have now reached over 100,000 subscribers. I want to say a massive thank you to everyone who has subscribed to the channel and helped us get this far. Now, I'm not over exaggerating here, but this is just the beginning. We've got so much more planned for the channel and for the company going forwards that I really can't wait to get to and show you. But today I want to do something a bit special and go back in time, back to the very first videos we made for this YouTube channel. And that was creating a door in Unreal Engine 4. I want to redo these and show you some really cool tips and tricks on how to make doors, as well as make an object that is more useful for designers in a big team setting. So let's get into it and make some doors. So here we are working on a door. And we're going to first of all create the door actor. So you're going to go ahead and create in your content browser a new blueprint class. And we're going to choose actor. And we'll name this one BP door. Now, as we want to design this well for our prospective designers and other people who are working on our game, we are looking to add numerous functions and functionality to extend out the ability this door has in our game. So first things first, we need to actually put a few elements in our component list here. So first up, we're going to put in a static mesh, and we'll call that the door. And the mesh we're going to use for this one is going to be, we'll just use a simple cube. Obviously, just be whatever mesh you would like to use. In this case, we're just going to use a cube. And we'll just scale it to a decent enough size. Like that. The main thing we want to do with this cube is if you're doing a sliding door, you want to make the location here 0, 0, 0, or better yet, put the proxy of where you want it to move at 0, 0, 0, and then attach the door. Now, what do I mean by proxy? Well, the annoying thing about placing this door in a scene currently as it is if I was to actually drag this into my level, you can see it's going to be half in the floor, which is annoying to fix because you have to keep dragging it up and all those things. So what would be a far better thing to do is to have this moved up like so. So it is no longer clipping through the floor of the root, but it's rather here instead. And further to that, it may even be better still to reposition this on the corner here so we can rotate this door as we see fit. The problem with this though is that as we are moving the position of the door, it makes it a little bit harder to calculate how much we should move it when we want to actually move or rotate it. So we're going to use a proxy. Now a proxy is just basically a scene component. And so we go add a scene component. And we want to have the scene sat at the root here. Okay, we want to sit at the root 0, 0, 0. We then want to attach the door mesh to that scene component. You do that by simply dragging your door onto your scene. Now, rather than moving the door around, we're going to move this scene around. As you can see here on the right, it's set to 0, 0, 0, and the rotation also 0, 0, 0. So I want to slide the door. I can do by simply moving it from 0 to whatever number I want. And also I can rotate it too from 0 to whatever I like as well. So having this scene component is really handy, especially if you've got different door meshes of different types. Next up is we want some sort of sensor, some way of knowing when the player is in range of the door or outside the range of the door. So make sure you don't have your scene or door selected when you're doing this, because what you don't want to have happen is have your box that you're about to add to this component list attach itself to one of these. If it does, it's not the end of the world. We can always detach it, but best case scenario is click on the default scene root, then click on add and search for your box collision. Now we want to move the box collision in position for the door. Again, somewhere that makes sense. And we make sure it goes on either side. Like so. The size of this depends entirely on how far you want it to be able to detect the player. But you're looking for roughly this sort of spacing. Obviously, you can decide however you want to handle it. But more importantly, as you can see here, the box component is not attached to the scene component. So if I move the scene, that box stays where it is. Okay, that's super important. So make sure everything's set to 0, 0, 0 regarding the scene, and we're good to now add it to our level. And because we've moved the thing up and around, it makes placing the door in our level that much simpler. Okay, so let's now work on the functionality for our door. Now, whenever I'm starting work on any sort of blueprint or any sort of actor, I like to plan out all the different things I'm going to need in terms of events, functions, and variables. And as I mentioned in the top of the video, we want to make this door as extensible as possible. So I don't want to be limited to what the door can do. I want to give the designer who wants to use the door as many different options as possible. So let's take a look at what we can do here. First of all, we can go down to our variables. The first variable we're going to have here is whether or not the door is locked. So I'm going to do is locked as a Boolean. Another variable we're going to have is determine whether or not the door should open as a sliding door or as a hinge door. So we're going to do variables here and do is sliding door. And both of these we're going to make editable. And you can do that by clicking the eyeball or changing the instance editable button to a tick on the right here. So the events, what we needed. The event graph is where we put things that are best used for functions that are going to be over time. So it doesn't the functions and events function very differently in terms of how they're executed. An event takes time to execute the full event, where the function executes entirely within that moment it's called. So things like latent events and functions can't be called in a function. So when we do a timeline to move something, we have to use an event. So let's make a timeline event here. We do on door open. Oh, make a custom event first. Usually helps. On door open. And on door open, we're going to have a timeline. And that timeline here is door opening. A timeline is ability to change a variable over time. To edit it, you just double click on it and it'll take you to inside that timeline. Now at the start it'll be empty, but we can add tracks to this for different types of values. We only need the float track. And we'll call this one position. You literally can call it whatever you like. But obviously it's best to name things that make sense. And this will be the position of the door. Now I'm going to give it a normalized graph. Now what normalized means is that the values will go from 0 to 1 only. And what that means, it makes it a lot easier to scale up and scale down what the speed is, how much it's going to do it, and everything else. It makes it a lot easier to manipulate. So I'm going to put in 2 points by holding down Shift and left clicking. And the first point will be set to a time of 0 and 0 for value. The second point will be set to 1 in time and 1 in value. Okay. Now, the timeline at the moment is going to keep on going. We need to bring that down. So go up to where it says length and change this to 1 second. Your graph should look something like this. This is what we call a linear graph. You can obviously change this to whatever type of graph you like by simply selecting these points, right-clicking on them. If I can right-click on them. Nice. There we go. Try again. There you go. We can choose what kind of interpolation we want. We can make it curved, for example. I'm going to leave mine as linear for now. We'll hit compile, and then with that done, I'm going to go back to my event graph via the tab up the top here. And you can see here, position is now an output pin on our timeline. And what we're going to do here is we're going to determine what position the door should be in terms of being opened as a sliding door or as a hinge door. So I'm going to create a function. And in this function, we will call set hinge position. And the set hinge position is going to have an input for a float. And that float here will be a normalized value. And that will be how far the hinge position is met. So we'll call this one interp value. Or actually, we'll change it alpha. We'll set to alpha. That'd make more sense. Then we're going to have also the maximum hinge distance. So this would be max hinge distance. So this is how far the hinge can open up. And we can set default values in here too. So max hinge distance, I'm going to set default to 90. And alpha should be left at 0. And on set hinge position, we're going to drag out our scene component, not the door, because remember we want to move the scene. And we want to rotate this thing. So I'm going to rotate it relative to its parent position. So set relative rotation. And in this case, we only want it to affect the Z axis. So it rotates in Z only. Now, the easy way of doing that is we're just going to split open our new rotation. And you can see now roll, pitch, and yaw are separate things. And you split by just right-clicking. And you can also right-click on them again and recombine them back up to their parent struct. But we want it split like this because we only want access to the Z new rotation. And what this is going to do is we're going to use the alpha here to determine the value for the yaw. So here we're going to use something called a lerp. Lerp will take the alpha into the alpha pin, and the return value will now go into the yaw value. And in lerp, we've got A and B. Now, what this does is that alpha determines how close it is to A and how close it is to B. So if we set A to 0 and B to the max hinge distance, this is going to make it so that when alpha is set to 0, the door will be closed at 0 degrees. And then when it's opened fully, the max hinge distance of 90 degrees will be set to B and therefore reach B, changing the rotation of our scene component. Now, whenever you're making functions like this, we do want to make sure we have a condition. Most functions, most events will have a start point and an effect, and usually will have a condition as well. Like, why would it ever do this? Okay. And what we can do is simply use our sliding door boolean we made and put that into a branch to make that false. So if it is not hinging, it will do this. Not sliding, sorry, it will do this. File, save. We're going to go back to our event graph and we're going to drag in our set hinge position. Put that in update, and the position alpha will go through. And I'm going to leave my max hinge distance to 90 right now, but we'll come across that in a moment. Next is we're going to do the set sliding position. So we're going to, again, create another function and do set slide position. And again, we need two inputs on here. One will be the alpha, and one will be the position. And the position, actually, we call this distance, max distance. There we go. That would make more sense. And we're going to set max distance here to, let's say, 250. We also want to know which direction we want to go in. So I'm going to put in a vector value in here, direction, and put in a vector. This can, so we can make it slide left and right or up and down. Or in some cases, you may want to go forward and backwards, but that's very rare. You mostly want to do the other two. So this works similarly to what we've done in the set hinge position. We're going to take the scene component, and then from there, we're going to do set relative location. And this is because we are changing its location relative to where it is currently in the world. We're not setting a brand new location, that's a world coordinate. We're saying take your world location and add or subtract this value from it. Okay, so here we go into now put in our condition in, which is going to be is sliding door, and we'll put that to true. And the direction and max distance and alpha will go into a lerp, like the hinge. So alpha would go into the alpha, and B would be the max distance. And the direction here will be multiplying by this value here. So direction will normalize this first of all. And why do we want to normalize it? Well, if the user puts in a value that's greater than the length of 1, so let's say they put in like 200, 200, 200. We don't want this value to be multiplied by 200. We want to normalize it down. So that 200, 200, 200 will become 111. So that's what normalize is going to do. And it just basically error proofs it for the designer. Now we can multiply this by our float and then put in the new location here. I'm going to go back to my input over here for set slide position and change the default value of my direction here. And we're going to change it to go in the Y direction. If you see from the gizmo in the bottom left here, Y is left and right. So I'm going to go in Y, set to 1. But obviously the player can put in whatever they like into that. Okay, now go back to the event graph and we're going to put that in here as well. Again, alpha will be our position that we want to go across to there. So now the door will do both. It can do a hinge door and it can do a slide door, depending on which way we want to go. So as with all things, once you start working on a project, you want to make sure you're testing throughout. So let's do a very simple test of making the door open when we come near it. So I'm going to go to the box collision and right click on it, add an event and do on component begin overlap. And I'm going to simply just tell this thing just to call the open door on door open event. So we can hit play and you can see it's going to hinge open. And if I want to change that, I can change this to its sliding door to be true. And it will slide. Now in the next part, we're going to be adding some more functionality to our door by the ability of unlocking and locking the door, as well as giving us the ability to open the door on automatic and closing the door on command via a enable and disable input. You can watch the next episode right now over on patreon.com/Ryan Laley, where you can find all my videos early before everyone else from just $1 a month. I want to say a massive thank you to everyone who has subscribed to the channel so far, and I really hope you're enjoying the content and excited to see where we go next with it. Thanks for watching. Bye-bye.